Surface is in a class of devices that makes use of modern standby to give you instant sleep and instant resume while using far less power than the traditional S3 sleep found in most PCs. Today, I'll walk you through how to generate sleep study and energy reports to help pinpoint the cause of power consumption that may be draining your Surface more than usual while it's in sleep. A high power consumption while in sleep means that the device is being interrupted from its lowest power state, drips, more than it should. If you're the administrator, you'll want to root cause devices that are experiencing this behavior. Let me show you how. Here, I'm remoting into the device of a user that is complaining that his device is losing power overnight. So the first thing is to start with powercfg/sleep study, and that will give me a report showing the power consumption while in sleep for the last few sessions. I'll also run a powercfg/energy report that will give me optimization tips for this device. Now that the reports are ready, I'm going to copy these reports to my device so that I can look at them in detail. Let's start by examining the sleep study report to find the active components during modern standby. It all starts with this graph. You'll see multiple colors and multiple styles of lines. You'll see dotted lines for when the device is charging, you'll see solid lines for when the device is discharging, and then you'll see colors. You'll see gray for an active scenario when the device is on, green for low system activity, orange for moderate system activity, and red for high system activity. In this case, we see lots of red, which is not what we expect. So let's look further. Down here, you'll see a table that describes every modern standby session lasting more than 10 minutes. You'll see the energy change, the duration, and the amount of time that it was in the lowest power state, drips. Ideally, each session should be in drips for about 95% of the time. So I would like to see a power consumption 7 to 10 times lower than the one shown in this graph. Looking at the latest sessions, I can immediately see session 8 being in drips for only 31% of the time and consuming about 5% of the battery in only 1 hour. And session 9 also shows me a higher than usual power consumption, with the device being in drips for only 81% of the time and consuming 1% of battery in only 23 minutes. Clicking each of the sessions will take me to a more detailed view. Drilling into session 8, I can see that Windows Update was responsible for most of the additional power consumption. This is something you would have planned, so there's no reason for concern here. Now in session 9, I see two things. One of them is the BI, that is the background infrastructure containing universal apps and system components. And the second one is Wi-Fi, that is consuming a lot more power than expected. And this is a concern to me. Let's find out what's happening. If I switch to the energy report, I can immediately see the issue. There's a red line pinpointing that the Wi-Fi is set to maximum performance while on battery. There's no way to change this in the UI, and yet it has somehow been changed. In fact, most power issues that we see on Surface devices come from administrators applying settings that are not meant for modern standby devices. So to fix this issue, I reverted the Wi-Fi power policy back to the default. 1 day later, I rerun the sleep study report and see a very big difference. The slope is less steep, and instead of red, now it's mostly orange and green. If you look at the table below, you'll see the same. You'll see that the table itself is mostly orange and green, which is good. What I do see though is that session 17 lasted for 16 hours and 18 minutes. Surface devices should automatically go into hibernation after 2 to 4 hours of sleep. This usually means that the device was reimaged and that the hibernation power policy was not applied. Let me show you how to do that. If you open the group policy edit and change the sleep settings, you can go to specify the system hibernate timeout on battery, and you can choose any value. Remember, this is set in seconds, so 7200 seconds would be the default. I hope today's demo bench helps you troubleshoot unexpected power consumptions while your Surface devices are in sleep. Keep checking Demo Bench for the latest information on Surface management and design. Thanks for watching.